Hi. Uh, in last few videos, we saw some example of exact differential equations. Exact differential equations are usually written in a differential form like this. And this is a linear first order differential equation. It's written like that. And in exact differential equations, we knew that the partial derivative of m with respect to y must be equal to the partial derivative of m with respect to x. This is the conditions of this for this equation to be an exact differential equation. And let's say if our equation is not exact, then in order for us to turn it into an exact differential equation, we can multiply it by an integrating factor. They show it by mu x. We can multiply the equation by mu x, that would turn that into an exact differential equation, and then we can solve it. So let's now find an integrating factor for a first order linear differential equation. So in order for us to do that, let's go ahead and write this in a differential form. So if we multiply both sides of equation by dx, we are going to have dy plus px y dx plus qx is equal to qx dx. Okay. Now let's write this equation as dy plus px y dx minus qx dx equal to 0. So we can write this as px y minus qx dx plus dy is equal to 0. Now we have written that linear differential equation into a differential form like this. So let's assume that this is not an exact differential equation. Let's go ahead and multiply this by an integrating factor mu x. So we have mu x. We are going to have mu x px y minus mu x qx dx plus mu x dy equal to 0. So we multiply this equation by this integrating factor mu x. So now this is our m and this is our n. in order for this equation to be an exact differential equation, the partial derivative of n with respect to y must be equal to the partial derivative of n with respect to x. So if we take the partial derivative of n with respect to y, we are going to have mu x px. So we are going to have mu x px equal to partial derivative of n with respect to x. Partial derivative of n with respect to x is mu prime x. So we can write this equation as mu prime x divided by mu x equal to px. Now, if we integrate both sides, we are going to have mu x, mu prime x over mu x dx equal to px integral px dx. Now, the integration of mu prime x over mu x is natural log of mu x is equal to px integral of px dx. So if the natural log of mu x is equal to that, then the mu x will be equal to the e to the power of px dx. So this is our integrating factor. So for our linear equation, we can use this integrating factor multiplied by our equation and solve. And in this video, I just wanted to show you how we found this, this integrating factor. It's very important for you to know the steps so that you can relate. This is, in reality, we are turning equation non-exact into exact and solve it like that. So if you understand the principle, it make everything easy in long run. So review these, and in my next videos we will solve a few examples using the integrating factor and solving the first order linear differential equation. So it is very important for you to understand how we are getting this. See you later.